Hey everybody, so now that we've gone over a few examples on why proper research ethics is necessary, let's dig into the specifics a little more. First, we can start with a definition of ethics. For our purposes, it's a branch of philosophy that is concerned with morality. This is what it means to behave morally and how people can achieve that goal. It can also refer to a set of principles and practices that provide moral guidance in a particular field. There's a pretty good framework to follow for thinking about research ethics. You can think of this in terms of weighing risks against benefits, acting responsibly and with integrity, seeking justice, and respecting people's rights and dignity. Simply put, research can only be ethical if the risks from the study are outweighed by its benefits. There can be several risks in a study, which can include physical or psychological harm, privacy matters, or maybe a clinical treatment that could fail to work. Likewise, there can be several benefits in a study, which might include having a clinical treatment that works, or being able to learn about science or contribute to science, or when participants receive money or course credit for participating in studies. But it's not always easy to weigh the risks and benefits of a study. Think back to the Milgram 1963 study. There are clear benefits to this study. It's a really important finding for psychology to know how far obedience to authority can be taken. But we know this at the cost of severe psychological harm to participants from that study. It's hard for people to draw the line on how far to take a study for the sake of scientific knowledge. People still debate this today, but it's important to design studies where the benefits clearly outweigh the risks. The next big area is to act responsibly and with integrity. You must carry out research in a thorough and competent manner. You need to know what you're doing well before you begin an experiment and make sure you cover all of your bases. It's important to be truthful and professional when conducting research. This promotes trust on multiple levels. It firstly gives you credibility as a researcher. It gives participants more faith and comfort in participating in studies in the future. It also helps to promote trust and the acceptance of scientific research in the public's eye. There's definitely no shortage of examples of untrustworthy research, and it can stifle scientific progress. A well-known example of this is Diederik Stapel. Diederik went from being an academic all-star, publishing many papers on human beliefs and attitudes, to being exposed as a complete con man. In many of his experiments, he completely made up data so that his experiments would work. Stapel was reported to say, "I tried to make it random," which of course was very hard to do. He would tweak his numbers so that the differences he found weren't too big to raise a flag, but small enough to still reveal significant effects or differences. This was systematic fraud, and university reports showed that Diederik had committed fraud in at least 55 of his papers and in 10 PhD dissertations written by his students. This sloppy science caused a lot of people to lose faith in the findings of this type of research, which isn't surprising. Diederik, after being blacklisted from academia, wrote a book about his experiences falsifying data. As a side note, some people didn't really like the idea of this guy profiting from academic misconduct, and so they placed free copies of his book online for others to download. There's a great piece about his story in the New York Times that details this. But overall, it's critical to conduct research truthfully for both participants and society, and to carry out research in a way that maximizes benefits and minimizes risks. The next area is about seeking justice. You must conduct research in a just manner. You need to treat all participants fairly and without bias. Historically, certain groups of people, especially people who are institutionalized, disabled, or belong to racial or ethnic minorities, have faced extreme risks in scientific research. Think back to the Tuskegee syphilis study and the horrible treatment of poor African American men in Alabama. Research should not favor one group or another, and in that way, it should be completely blind. Another aspect of seeking justice is making sure to properly compensate research participants. Most of the time, this is done by just paying subjects in accordance with state minimum hourly wages. But other times it can be in exchange for course credit, which is commonly done at universities, where introductory psych courses require students to participate in research or alternatively complete like a writing assignment or an essay of some sort. An interesting case on the ethics of participant payment is Amazon's Mechanical Turk. This is an online platform where people can post odd jobs where workers can complete them across the globe from their personal computers. This actually is an interesting pool of people that can complete different research experiments. Oftentimes, subjects are paid incredibly poorly, sometimes even 25 cents for a 10-minute study. For studies that are 30 minutes or more, oftentimes subjects get paid less than $3. While workers on Mechanical Turk are technically independent contractors and they voluntarily accept those wages, a lot of workers depend on those wages. And this brings up debatable ethical considerations on if these workers are being compensated properly for their participation in research. Next is respecting people's rights and dignity. As researchers, we must respect participants' autonomy. And autonomy is the right for someone to make their own choices and take their own actions free from coercion. Participants can decide to participate in experiments, and they can decide to prematurely end experiments free from penalty. For every participant in every single study, there needs to be informed consent. This is a written document that requires verbal agreement as well as a physical signature of the participation, detailing that they agree to participate in the experiment and are well aware of the details of the study, risks and benefits, what the study means to them, and all of the expectations of them that might otherwise influence their decision on whether they want to do the study or not. Lastly, we need to respect their privacy. They have the right to decide what information about them is shared with other people. With that, we need to maintain confidentiality, which is an agreement not to disclose participants' personal information without their consent. It's important to distinguish confidentiality from anonymity. Anonymity is the practice of ensuring that an individual's name is not directly associated with the information or measurements obtained from that individual. Subjects should be anonymous if at all possible. Data as well as identifying information are usually stored in locked file cabinets or on password-protected computers or on secured university servers. It may not be possible to eliminate ethical conflicts entirely, but it is possible to deal with them in a responsible and constructive way. We continually need to be thinking about potential ethical issues, how to minimize risks, and how to explain those to subjects. There are specific codes that exist that are both enforceable and that provide guidance on issues that happen often. As a side note, we can differentiate between rules and standards. Ethical principles are the general ethical guidelines, and the ethical standards we talk about are the ethical rules we follow. One of the first ethical codes was the Nuremberg Code. This is a set of 10 principles written in 1947 from the trials of Nazi physicians accused of cruel experimentation on concentration camp prisoners in World War II. This provided one of the first standards on how to compare the behavior of men on trial. The Nuremberg Code was clear about the importance of weighing risks and benefits and the need for informed consent. Think back to the last video about some of the cruel experiments some of those prisoners went through against their will. Another ethical code started in 1964, and that was the Declaration of Helsinki. This code was created by the World Medical Council and was similar to the Nuremberg Ethical Code. It actually added to or extended the Nuremberg Code by saying that any research that involves human participants needs to be based on a written protocol, which is a detailed description of the research that is reviewed by an independent committee. The Belmont Report, written in 1978, presents federal guidelines that were based off of the problems with the Tuskegee syphilis study. 3 main principles from the Belmont Report include seeking justice for participants, which ensures that risks as well as benefits are well distributed across groups at the societal level. Respect for persons, which essentially means a need for informed consent for all participants. And this report recognizes the principle of beneficence, which shows the importance to maximize benefits while minimizing harm to both subjects and society. Nowadays, universities, hospitals, or really any institution that receives any kind of federal support are required to house an Institutional Review Board, or IRB for short. An IRB is a committee that is responsible for reviewing research protocols for potential ethical problems. IRBs review every research protocol from an institution, and you aren't allowed to run any experiments until you get IRB approval. There has to be at least 5 people on any given IRB, but it could be more people than that. These people have to come from different backgrounds of mixed genders, must be at least one person that is totally unaffiliated with that institution. It's the IRB's job to help make sure that risks are minimized, that the benefits clearly outweigh whatever risks there are, and that research is performed in a just and fair manner, and that all procedures, informed consent, and post-experiment debriefing is up to standard. The code that psychologists use today are determined by the APA in their ethics code. You can find the entire ethics code for free online, but the most relevant part for us is Standard 8, Research and Publication. We will go over parts of this code in this lecture, including institutional approval, informed consent, participation, deception, debriefing, care and use for animals, reporting research, plagiarism, and publication credit. First and foremost, every project needs to be approved. This is done by submitting a research protocol to your local IRB for approval. Next, for every subject, you need to have an informed consent sheet for subjects to sign. I know we've touched on this a little bit already, but it should detail what your study is about, what they'll be doing in the experiment, what the risks and benefits are. Be sure that it's known that this is completely voluntary, and state what the type of compensation is for participating. Usually it's money or course participation credit. It's important to know that it's not just about getting a signature and moving on. Subjects shouldn't only read through the informed consent document. You should also verbally describe and explain it to them as well. Participation. It has to be clearly described to the participant that doing the experiment is voluntary. They can choose to do it or not. They also have the right to fully complete the study or stop it halfway through without any kind of penalty. A lot of times at universities, undergraduates fulfill a course requirement for doing experiments, but since participation is completely voluntary, undergrads aren't actually forced to do the experiments. In classes that require some type of participation, there's usually an alternative assignment like an essay people can write in the case that they don't want to do any experiments. The rule on deception is that you don't use deception in your studies unless it's critical to your research question and you can justify it scientifically, educationally, or if it has some type of applied value, and that it's not feasible to use non-deceptive alternatives. But there's a hard and fast rule that you don't use deception if it's going to involve any kind of physical or psychological harm or pain. There are 2 types of deception that we can categorize. The first is passive deception, which is withholding or omitting information. With this, you don't intentionally tell something about the study. An example of this could be not telling the participant the real reason for the study, but not exactly telling them anything else either. The second type of deception is active deception. This is presenting misinformation about the study to participants. An example of this is telling the participant your study is about one thing when it really is about another. After every experiment, participants need to be debriefed. This gives them an opportunity to get the appropriate information about the study, like what it was really about, what results will there be, the reason why the study is being run, and it also serves as a step to correct any misconceptions or reveal any deceptions. Debriefing subjects also provides resources in case they have any questions for you or the IRB, or any other resources offered through the institution or university. So for the use of animals in research, there's extra training that researchers have to go through. But generally, there are federal, state, and local laws that researchers follow regarding how they get animals, how they're cared for throughout the experiment, and what to do with animals after the experiment. We won't go into too much detail about this here, but essentially you have to ensure that you minimize to the best of your ability any discomfort, illness, or pain animal subjects might endure. If there's any at all, you need to be able to justify it scientifically to your local IRB. Okay, when it comes to reporting your research results, rule number 1 is do not fake your data. Think back to the fraudulent case of Diederik Stapel. And if you do happen to make any honest mistake in your project, it is your responsibility to correct those errors. If your research paper has already been published, you'll need to post a correction or have the paper retracted if the error isn't correctable, or post some type of commentary on the article. While scientific fraud will get a researcher blacklisted from academia, errors are honest mistakes that happen in the research process. Researchers are human, and mistakes happen to everyone. Now, fraud can be motivated for various reasons. The biggest reasons people commit scientific fraud are mainly because academia is extremely competitive. It's this idea of publish or perish. To be able to maintain a tenure-track professorship, you need to continually publish research papers. You either publish and keep your job, or perish and lose your job. This can put a ton of pressure on researchers to tweak the numbers or fake your data. Researchers also need grants, and they need to keep their labs funded. This can also put pressure on researchers. There are several other reasons for this as well. It's hard to pinpoint when fraud happens, and it's a pretty serious accusation to make of someone. So a good safeguard against different types of fraud is replication. Replications are when you repeat an experiment someone else has done to see if you get the same result. There are a couple types of replications that researchers can choose from. An exact replication is when you quite literally run the same experiment. That means using the same stimuli and reproducing the same methods from the original experiment. Conceptual replications are replications that are very similar to the original experiment, but differ in a few ways. Usually, the method and tests are the same, but there are small tweaks such as the type of stimuli used, or how long certain stimuli are presented for, or changing the number of groups, for instance. When we run replications, and sometimes there are many replications for important papers, we can gain more confidence in the original finding if all the replications are showing the same thing. If replications show mixed results, one thing here, one thing there, as a field, we might have a little less confidence in that original finding. Okay, just a few more topics I'll quickly go through. Plagiarism. Hard and fast rule of not copying others' work. Self-plagiarism, however, is a little trickier. I know researchers who have debated this before on whether they think this is okay or not, but for our purposes, we'll say that any type of plagiarism is just not acceptable. Publication credit. If you've done any work or contributed to a project, you are entitled to be credited for your work. It's important to say that just because someone holds a position of power doesn't entitle them to authorship. For example, just because someone is a department chair doesn't justify authorship credit. Only work performed is justification for credit. Duplicate publication of data. As researchers, you're allowed to publish data once and only once. It is considered unethical if you take data that were previously published and attempt to publish them again in another paper as new data. Sharing research data. You also have a responsibility as a researcher to share your data if a competent professional requests it. If someone is trying to verify your results, you'll need to be able to share your data, any code associated with the project, or experimental materials. Science at its core has to be reproducible. And finally, a quick note on reviewers. As a researcher, if you ever review someone's work that is submitted for a presentation, a research publication, or grant, or any type of proposal, you need to keep that confidential. You can't scoop their idea or share it with anyone else. You need to respect the confidentiality and proprietary rights of the information for those people who submitted it. Okay, so that's it for this video. See you all next time.